In this video, I will discuss few problems on normal distribution with complete solution. In this example, mean and standard deviation are given. We have to find the probability when the normal variate x lies in between 3.43 and 6.19. To find the probability between these two numbers, first we convert these x values into standard z variable. See, what are the given values? Mean mu equal to 1 and standard deviation sigma equal to 3. First, we convert x value 3.43 into standard normal variate z. Already we know the formula z equal to x minus mu by sigma. We have to substitute all the parameters in this formula. That gives 0.81. So when x equal to 3.43, then corresponding z value is 0.81. Similarly, for the second x value 6.19, when x equal to 6.19, then the corresponding z equals to 1.73. See, we converted given x values into standard normal variate z. Now we find the probability when x lies between 3.43 and 6.19. See, this is exactly equals to probability when z lies in between 0.81 and 1.73. To find this probability, we use normal distribution table, z table. To use the z table, first we have to know how to use the z table. For that, we are constructing one normal curve here. You can see here. And the most important thing, first we mark the z values on this normal curve. See, if z values are positive, then you have to mark z values right to the mean line. If z values are negative, you have to mark the z values left to the mean line. So here z value is 0.81, 1.73, both are positive, so we have to mark on right side. You can see 0.81 and 1.73. Now, probability between 0.81 and 1.73 means we have to consider the area between 0.81 and 1.73. You can see the green line. Okay, this is the required area, means that gives the required probability. To find this area, we have to use the z table. Now, we will see how to use the z table. See, first I'm taking one more curve here. Look here, I'm marking only 0.81 on this curve. The table always gives the left side area of the z value. Means in this second curve, you can see, if you see the table, from the table you will get this area. See, this is the area you will get from the table. If you see 0.81 in the table. Okay, I will show how to see the table next. From the table you will get here. And one more thing, I need one more value for z equal to 1.73. For that I am taking next curve. See, from the table we get the left side area of z equal to 1.73. Okay, so what is this area? See, the left side area of z equal to 1.73 is 0.9582. Okay, similarly the left side area of z equal to 0.81 is 0.791. Now what you need? The area between these two z values, means you need this required area. Okay, see in the first curve. See, how do you get this? See, from this total area, you have to subtract this one. Okay, How do you get that? From this total area, you have to subtract this part. That gives the area between the two z values 0.81 and 1.73. Now you can see that value here. What is the value? So 0.1672. This is the required probability. So what is the procedure here? Once again, you can see we are converting x values into standard normal z values by using simple formula z equal to x minus u by sigma. Okay. To find the required probability, we are taking the area between the two z values with the help of z table. Now you can see the second example here. Similar question. Okay. Now you can see. First, we are converting x values into z values with the help of z formula. So when x equal to minus 1.43, z corresponding z is minus 0.81. And when x equal to 6.19, corresponding z is 1.73. Next, what do you need? Probability between, okay, actually this is not 3.43, this is 1 minus 1.43. Okay, this is 1 minus 1.43. Okay, we need probability when x lies in between minus 1.43 and 6.19. So we converted these x values into z values. We have to find the corresponding probability when z lies in between minus 0.81 and 1.73. We have to follow the similar procedure. First, we have to consider the normal curve. You can see the normal curve here. Okay, already we discussed how to mark z values. If z is positive, you have to mark right to the mean line. If z is negative, you have to mark left to the mean line. Okay, you can see minus 0.81, it is negative. So we have to mark on left to the mean line. 1.73, we have to mark on right to the mean line. Now, what do you need? We have to find area between these two z values. Okay, you can see that green lines. Okay, this is the required area. Okay, we can't find this area directly from z table. So what is the procedure here? First, you have to consider one z value minus 0.81. Already we know the table always gives the left side area of z. So for minus 0.81, see left side area. You can see here left side area. See green lines. From table you will get this area. Okay, what is this area? 0.209. Similarly, already you know what is the left side area of 1.73. You can see this graph, left side graph. Okay, when z equal to 1.73, what is the area from the table? 0.9582. From this total area, I have to subtract 0.209. That gives the required area. What is the required area here? Now you can see the required probability here. 0.9582 minus 0.209. So the value is 0.7492. This is the required probability. See how to see the z table. Suppose when z equal to 0.81, the probability is 0.791. You can see z equal to 0.81. Now we will see how to find the area under the normal curve for the given z. See in our previous example, z equal to 0.81. See, z equal to 0.81. We have to mark this positive value right to the mean. Okay. Now we can find the area left to this z value from the table. Means we can obtain this area. You can see the green lines. That is the area we have to find from the table. See in this table, first column, you can see the first column, these are the values of Z. In this first column, you can find 0.8. See, where is that 0.8? You can find here 0.8. Okay, but the number is 0.81. So here 0.858, and in top row you can see 0.01. So this is 0.81. What is the corresponding value for this? See, this is the corresponding value, 0.7910. Okay, so the area left side to the Z is 0.7910. You can see this. Similarly, in the last example, another Z value is 1.73. See, if Z equal to 1.73, what is the area bounded by the curve? See, again you can see the left side area of Z value. We can find this area, this value from the table. See, 1.73 in first column, you can see 1.7. 1.7. See, this is 1.73. Where is 3? On top row, you can see 0.03. So this is 1.73. Corresponding value. What is the corresponding value here? 0.9582. Look at this, 0.9582. Now it is clear how to find the area under the normal curve for the given Z value from the table. You have to observe one thing, this table for only for positive Z values. Now we will see table for negative Z values. Now you can see the table. This is the table for negative Z values. Suppose Z is negative. See, here we are taking Z equal to minus 1.73. See, already you know, if Z is positive, we have to mark on right side. If it is negative, we have to mark on left side. So here minus 1.73 negative. So we have to mark on left side. Okay. Now the area under that normal curve is the left part of minus 1.73. Now you can see that green color. Always the table gives the left side area of Z value. So that green color, we have to find that green color, the area of the green color. Okay, we can find that one from the table. Very careful. Here Z is negative means we have to see the negative table. Okay, minus 1.73. First column, minus 1.7. We have to see minus 1.7. Minus 1.7. See, this is minus 1.7. 3 means you have to see top row. Corresponding number. What is the corresponding number for this? See, this is the corresponding number, 0.0418. This is the required area. You can see here. For negative Z values, always you have to use negative table. Okay. Now, suppose Z equals to minus 0.81. Okay, minus 0.81. Again, minus 0.81 means Z negative. So you have to mark left to the main. Okay, now you can see from the table we can find the left side region, area of the left side region of that Z value. You can see the green color. Now we have to see minus 0.81, minus 0.8. See, this is minus 0.81. 1 means you have to see the top row, minus 0.81. Corresponding value. Look at this. This is the corresponding value 0.209. Okay. So this is the area. For positive values, we use positive table. For negative values, we use the negative table. And table always gives the area of the left side region of the Z. Now, we will see another example. In this example, given mean equal to 30 and standard deviation equal to 5. Now, we have to find the probability when x less than or equal to 45. See, with the help of given mean and standard deviation, we can convert this x value into standard normal variate z. Already we know the formula z equal to x minus mu by sigma. By using this formula, we can convert given x into z. So here z is 3. To find the required probability, what is the required probability when x less than or equal to 45? We have to find the probability. This is exactly equal to p of z less than or equal to 3. To find this value, we consider the normal curve. Okay, here z equal to 3, positive value. Already we know if it is positive, we have to mark on right side. Next, by using z table, we have to find the corresponding area. But z table always gives left side area of the z value. See this green color region. The area of the green color region we can obtain from the table. The value is 0.998. Now look at the question. We need probability when z less than or equal to 3. Less than or equal to 3 means the left side area of z. Okay, already we got that area from the table directly. So what is the required answer? 0.998. That is the required probability. Now the second question. When x greater than or equal to 45, we have to find the probability. So we will get the same z that equal to 3. Now we have to find p of x greater than or equal to 45. That is exactly p of z greater than or equal to 3. Because we converted x into z, that is 3. 3 is positive, so we have to mark on right side. And the table gives the left side area of z value. See, the area of the green color region. We can obtain this value from the table. But what do we need? Here, probability when z greater than or equal to 3. Z greater than or equal to 3 means we have to consider the right side area of z. But table gives left side area. So actually we need the right side area. Right side area means we need this area. Okay. So how can we obtain that area? Already you know the total probability or total area under the curve is 1. So to find the right side area, we have to subtract the left side area from 1. See, the left side area is 0.998. We have to subtract it from 1. So what is the right side area? 0.00135. Now the required probability is 0.00135. In this example, 7% of the items are under 35 and 89% are under 63. Determine the mean and variance of the distribution. See, in last two examples, mean and standard deviation is given. We have calculated probability. But here, probability is given. Now we have to find mean and standard deviation. See, what are the given values? 7% of the items are under 35. Under 35 means, suppose x is less than or equal to 35, then the probability is 7%. 7% means 0.07. Similarly, 89% are under 63. Means when x is less than or equal to 63, the probability is 89%. 89% means 0.89. Okay. Now, if x equal to 35, then what is z? Z equal to x minus mu by sigma. We know x. So 35 minus mu is unknown, sigma is also unknown. In second case, if x equal to 63, then what is z? X minus mu by sigma again. So 63 minus mu by sigma. Okay, so we don't know what is the z exactly. If we know z value, then from these two equations we can calculate mu and sigma. Let us see what is z. See, given 7% under 35 and 89% under 63. Okay, we consider normal curve. Already you know, in the normal curve, the total area under this curve is 1. So this mean line divides the total area into two parts. Left side area 0.5 and right side area is also 0.5. Okay, now in first case, see, given 7%, 7% means 0.07. Okay, 0.07. We have to consider this area under the normal curve. Now you can see in this normal curve, I have to consider 0.07. 0.07 means it is less than 0.5. So how to take completely on left side of the curve. You can see in the graph. See, I am taking that 0.07 area left side of the curve because it is less than 0.5. Okay, this is 0.07. Okay, now second case 89%. 89% means 0.89. Okay, this is greater than 0.5. So how to mark on right side? See, now look at that. How to mark the z value on right side? Okay, but given when x is less than 63 means left side area of this mark. So this is 0.89. See, already we have the areas left side of that z. So easily we can find these z values from the table. In first case, see, this z lies on left side. Okay, this is on left side. So always we consider negative values because this z exists left of the main. So your z is negative. If you see this 0.07 area in that z table, you will find here, okay, I'm writing here. In first case, this is from formula. Now from table z equal to, if you see this 0.07 in the table, you will get minus 1.48. Okay, similarly in second case, z is, see, if you see 0.89 in the table, see, this is right side, so your z is positive. So z value is 1.23. Z is 1.23. Okay, now you can see from formula, in first case z is 35 minus mu by sigma. From table it is minus 1.48. So we have to equate these two. Similarly in second case, from formula z is 63 minus mu by sigma. From table z is 1.23. So I can equate these two. So what is the result here? In first case, 35 minus mu by sigma equals to minus 1.48. In second case, 63 minus mu by sigma equal to 1.23. Okay, left hand side we got from formula, right hand side value we got from table. Okay, by solving these two equations we can find mu and sigma. Okay, so see, from normal subtraction we can obtain here 28 by sigma equal to 2.71. Okay, this implies sigma equal to 10.00. 332. If you substitute this sigma value in any one of these two equations, you can obtain mu. So your mu equal to 50.3. Okay, so what is the question? Determine mean and variance of the distribution. So finally we got mean equal to 50.3, but your sigma is standard deviation. We need variance. So what is the variance here? Variance equal to sigma square. So sigma square equal to, what is the answer? By squaring it, you will get 106.75. Okay, in first two examples, mean and standard deviation is given. We calculated probability. In this example, probabilities are given. With the help of the formula and table, we are finding mean and standard deviation. In first two examples, we know the z values. By using those z values, we are finding the corresponding areas with the help of this z table. Now, in this particular example, areas are given. Okay, now we have to find the z values. See, already you have seen what is the first area. The first area is 0.07. 0.07 means, see, already you know there are two tables, one for positive z values and second one for negative z values. Okay, so first area is 0.07. See, 0.07, can you see in this is the positive z values table. See, here you can't see 0.07. Okay, so we can go for the negative z value table. In negative z value table, you can find here, in this table you have to find 0.07 in the middle of the table. Okay, we have to identify. The value is, you can see here, 0.07. I think we can't see exact 0.07. So better to choose its nearest value. Okay, the nearest value is 0.07, nearest value. Okay, you can take this one. Okay, what is the corresponding z? Okay, you can see here minus 1.4 and 0.08. So the z equals to minus 1.48. Okay, see, once again look at this. You can't see 0.07 exactly, so we can take its nearest value. Or you can also choose this one, there is no issue, 0.070. Okay, in this case minus 1.47. Okay, either this one or this one you can use, minus 1.47. Okay, so in this example, areas are given. We are finding the corresponding z values. Given two areas. Okay, one is 0.07 and second one is 0.89. Suppose 0.89. Okay, in this table, where can you see that 0.89? Maybe you can find the exact value, or you can consider the nearest value for 0.89. 0.89, you can see here. Okay, you can see this one. One second. 0.89. Yes. Okay, we are taking its nearest value. So you have to consider the corresponding z value. What is the corresponding z value here? 1.23. Okay, this is the required z value. Okay, suppose z values are given, then you have to see the z value in the first column and find the corresponding areas in the middle of the table. Suppose areas are given, then you can see you have to identify the exact value or its nearest value in the middle of the table and take the corresponding z value. Now we will see one more example here. See, here also areas are given. First we have to find the z values, then mean and variance. Okay, So first condition, what is that? In a normal distribution, 31% of the items are under 45. Under 45 means you can see here, suppose x is less than or equal to 45. Okay, what is the probability? It is 31%, means 0.31. Okay, now we can convert this one into z value. So what is the formula? Z equal to x minus mu by sigma. Okay, z is unknown. So what is x here? 45. Mu, this is also unknown. Mean is not given. Sigma, standard deviation, is also not given. Okay, now second condition, 8% or over 64. Over 64, when x greater than or equal to 64, the probability is 8%. 8% means 0.08. Okay, we are finding the corresponding z value. 64 minus mu by sigma. Okay, these are the z values from formula. Now we will take z values from the table. Okay, you can see the graph once here. See, 31% or under 45 means when x is less than or equal to 45, the probability is 0.31. Means the area is 0.31. Very careful. If the area is less than 0.5, you have to mark on left side of the main line. Okay. If it is greater than 5, we have to consider area from right side of the main line. Okay. You can see completely we have to consider this area from left side of the main line. You can see the area. This area is 0. This is 0.31. Okay, from the table we have to find the corresponding z value. When it is 0.31, the z value is, we have to use the table here. So from the table we can write here, okay, this is from formula. This is the z value from formula. Now I'm writing z value from the table. From table, z equals to minus 0.5. Okay, you have to observe that for the given area, given probability, z equal to minus 0.5 from the table, and this is from formula. Similarly, second condition, 8% over 64. When x is greater than or equal to 64, the area is 0.08. Over means you have to take the area right side of 64. Okay, very careful. Less than means you have to take the area left side of the z value. Over means above, or over means right side of the z value. Okay, see 0.08. So we have to mark on right side. Okay, you can't mark this one on left side. Suppose if you mark here, see over means you have to take the right side area, means you have to consider this area. This is not 0.08, this is more than 0.08. Okay, so over means over and 0.08, that is very less than 0.05. So we have to consider this side. Okay, now the corresponding, see, already you know z table gives only left side area of the z. Okay, the table gives always left side area of the z. Okay, so what is the left side area now? Right side area is 0.08. What about the left side area? Already we know the total area under the curve is 1. So 1 minus 0.08 gives the left side area, that is 0.92. So in the table we have to see 0.92. Okay, very careful here. Don't see 0.08 in the table, because table consists only left side areas of the Z. Okay, 0.08 is the right side area. So don't see this value in the table. You have to see in the table 0.92. That is 1 minus 0.08. Okay. Suppose if you see 0.92 in the table, okay, we have to find the Z value. From table, okay, see once again look at this. This is the Z value from formula in second case. Now we are finding Z value from the table. From table Z equal to 1.4. Okay, you have to observe. See, one value we are getting formula and one value we are getting from table. So we have to equate these two values. So in from first case, we can write 45 minus mu by sigma equal to minus 0.5. In second case, 64 minus mu by sigma equals to 1.4. Okay, left side values are from formula, right side values are from table. By solving these two equations, we can obtain mu and sigma. So what is the mu here? If you calculate, if you simplify this, here mu equal to 50. Okay, standard deviation equal to 10. See, these are the required values. Now we will see how to choose the values from the table in the last example. See, first case it is given 0.31. This is 0.31. Okay, now we have to see in the table. See, in this table we have to see 0.31. 0.31. See, 0.31 is less than 5. Okay, less than 5 means we have to see the negative Z values. Okay, next table. So 0.31. Okay, here. This area is 0.31. Okay, if you see 0.31 here, here you can see here 0.31. We have to consider the nearest value. Nearest value, you can take this one 0.308. What about the corresponding Z value? Minus 0.5. So your corresponding Z value is minus 0.5. See, second value is the area over 64 is 0.08. So this is the area over 64, that is 0.08. Okay, so this is 0.08. See, but in this table we don't see the 0.08 because this table consists only left side values. Left side values means, see, these are the value. This value exists in the table, not the right side value of the Z. So 0.08 means 1 minus 0.08. Total area is 1. So that is 0.92. Now we have to see 0.92 in the table. See, what about 0.92? We can see 0.919. We can't see exact 9 value. So we have to consider the nearest value 0.9192. So what is the Z value here? Z equals to 1.4.